Okay, I got the last two homeworks graded back for you. So you should turn them both in. You should have two. Okay, suggestions for homework problems we should go over. Test tomorrow.
99.
What's that? I heard 98 and 99. $66? 98, 99, 66 have been suggested. What else? 79, almost in unison. What's that? You like it? You're good? Last chance. Yes, important. Oh, good. Let's get all the picture. Let's try this. There we go. Here is 66. So it shows that the bottom of the wheel is 0.7 feet above the water. The radius is 12. We want to sketch the height in feet above the water as a function of the angle of rotation measured in radians. So one thing we can do that will help us here is let's put our y-axis right next to it. We got space there, that's nice. And then the x-axis at the water level. That way things match up here, right? The height of the bucket matches right up with our y-coordinate. Okay? Like that? Okay, so this x-axis is what quantity? No, what quantity in general? What changing quantity is our x-axis?
Along the x-axis?
Angle measure, right? Theta. So that's going to be 0. So we could do 2 periods, say. 0, pi, 2 pi, 3 pi. 4 pi would that be 2 periods? That would be, angle measure. If it's a straight angle measure, then it's going to make 1 period every 2 pi, right? Okay? So the height of the bucket at 0 is what?
12.7 feet.
12.7, which is going to match up right here. There's 12.7. And then at pi over 2, so 1/4 rotation, height of the bucket will be this high right here. So let's just mark off these heights right here. See that? So the height of the bucket will just be right matching up with our y-axis. That'll be easy. So at pi over 2, where will the bucket be? 24.7 up at the top. At pi, where will the bucket be? It'll be here. So it'll be at 12.7 again. 3 pi over 2? 0.7? 2 pi? Back to the midline. So we have a function that literally describes this very thing, vertical height above the horizontal diameter. What function is that? You're all thinking it, right? Vertical distance above the horizontal diameter? It's our sine curve, right? What coordinate is that? X coordinate or Y coordinate? Y coordinate. See how good of a... So do I make straight lines like this? No, we spent a whole day seeing that those changes are great at first, but then the increases start decreasing, right? The changes decrease. And then we have something like that. Okay, so that's one cycle. All right, so that's sketching the graph. Define a function that represents the bucket's distance above the water in feet as a function of the angle. So is that the same one that we just drew? Do we have the same input and output for A and B? Or what we drew and what we're gonna do here? Yes. So you told me this is a sine, but it also could be cosine with a horizontal shift. We talked about that last time, right? But it's more convenient just to use sine, then we don't have to worry about a shift. So we'll just do sine of theta. Okay, so that just gives us radius lengths above the horizontal diameter, but we want feet. So how do we get it to be feet above the horizontal diameter?
12.
Going to multiply by 12. Now that has a center line of what? What does that have a center line of? Y equals? That would be a center line of y equals 0, like this. It would be, what we've got so far would just look like this. So what do we need to do to the center line so that the graph is in the right place? Move it up 0.7, right? This is the most common mistake students make. They say, oh, the bottom of the wheel is 0.7 up, so we're going to move that sine curve up 0.7. It's not right, right? Because if we move it up 0.7, we'll get this. Red for wrong, okay? Red for wrong. If we move it up 0.7, this is what we'll get. That's not tracking the height above the water, right? We've got to move the center line up, then the whole graph gets in the right place. So how far up? 12.7.
So your center line is what you
Get your center line right. Get your center line to where the center of the rotation is, and everything else will fall into place. Yep, exactly. Questions on part B? All right, now we want to G that the bucket's distance above the water, same output, as a function of the number of feet rotated. So what's going to change then in this equation when we do G? What's that? The input's going to change. Now we want, as a function of number of feet, call it n. N for number of feet. So that input's going to change. So we still want the radius to be 12, or the amplitude. So the question is, what goes in here? Plus 12.7. So this is still going to represent theta, but we just need it in terms of n. It's still going to represent theta, but we just need it in terms of n. What's that? 2 pi n. So let's think about this. Theta is the number of radius lengths, right? So if theta is the number of radius lengths, how do we get number of radius lengths from number of feet? So we want theta equals, so how do we get the number of radius lengths from the number of feet? So if the number of feet was 24, how many radius lengths would that be? That'd be 2. We'd want theta to be 2. If the number of feet was 36, that would be 3. If the number of feet was 6, we would want theta to be a half. So what are you doing every time to the number of feet to get the number of radius lengths? Yeah, you're going to divide by, so whatever the number of feet is, if you divide it by 12, that gives you the number of radius lengths. And that's the same as the angle. So we want n over 12. And that goes back to our theta times r equals arc length, right? So theta r equals s. Here we just called the number of feet, we called it n. We're solved for theta, so it's n over r. Questions on 66? Are we good? Next one we asked for 79. Is that right? Okay, so we can only have time for all four. So are there two of these that are good to do? So now this is putting it all together. These are great problems, so maybe we can do two of these. A, B, C, or D. Suggestions? I heard A and C. C for sure. We're going to do C. What else do we want to do? A?
Let's get B, because it goes underneath.
I agree. So, and I can get them both on the same page there. So how about B and C? We'll do B and C. So we'll start with B. So what's easy? So let's talk about what's easy to identify first. So I think what's easy to identify first is the max and the min. Okay, max and min. So max and min. What do we got? Max is 2. Min is -4. From those two, we can easily get midline, right? The average of those two will be the midline. We know that's really important. And it is -1. So here's our midline. Let's draw it. That's key because we need to know where in terms of getting shift and all this period stuff, we need to know exactly where vertically where the middle of this thing is. All right, so we got the midline. So what do we want to do next? How about the period? How do we pick the period off given the graph? Lots of ways to do it. So there's basically 3 ways to do it. Period is how far it takes, what interval before it starts over again, right? What interval before it starts over again. So how can we use the max to do that? From one max to where would we stop for the period? Next max, right? So from there to there, that may be the easiest. So we go from 2 to 5. Oh, it's a little bit more than that, because look at when we get to 8, do you see it's further than 8. So period goes from about 2 to maybe 5.1, which is 3.1. What might this period be here? Yeah, they're probably showing us a period of pi. We'll go for it, right? So we'll just say it's pi. I'm guessing that the period's pi. But we don't know for sure. So 3.1 would be acceptable. Even 3 would be acceptable. But if you look a little more carefully, look at 8. You're seeing that it's greater than 3. Okay, so 3.1 or pi, this is all estimating. So we'll use pi, but 3.1, both are acceptable. Okay, what else do we need? Amplitude. What's our amplitude? That falls in with this stuff up here, right? The amplitude is 3. Okay, so we can start making a go at this, and then we'll do the horizontal shift later. So do we want to use sine or cosine? Doesn't really matter because we don't have either one, okay? We don't have either one. We're going to need a phase shift, whether we use sine or cosine, because here's sine would start at the midline, cosine would start at the max, right? So, which we'll do sine, okay? We'll do sine. So, we're going to do a sine function. Do we have a coefficient to the sine? Amplitude. Are we raising this up or lowering it? Lowering it by -1. So that's going to be our midline. So what we got left is what we're taking the sine of. So if the period is pi, so in general this thing looks like b theta, right? B has to do with the period. So we want b theta to equal, we need the value of b so that b theta is 2 pi when truly theta is pi. So when we make one full rotation, one period, we need that whole thing to be 2 pi. Does it make sense? So when theta makes a full cycle, we need what goes into sine to be 2 pi, because that's what sine corresponds to sine being a full cycle. So what's our value of b? That one's easy. Nope. So when theta is pi, we want b theta to be 2 pi so that we have a full cycle of sine. Because that's what we got. We got a full cycle every pi. So what's the value of b that will make this 2 pi when theta is pi? Just 2. No, just 2, right? We need b theta to be 2 pi, one full cycle, when theta makes one full cycle of pi. So b times pi has to be 2 pi. Therefore, this coefficient is 2. Okay, he said it's rotating twice as fast. That's another good way to think of it. If our period is pi, it's actually rotating twice as fast as what the normal sine would do. So how do we get it to rotate twice as fast? We want 2 theta instead of theta. Yeah, absolutely. Another way to think about it. So the last thing, so what did we just graph? We just created this. Starting at where? Max, midline, or min? If it's 3 sine 2 theta minus 1. We just started at the midline. And then in 1/4 period, so here's the full period here. We'll be back at the, so half of that is about 1.57. Half of that's about here and here. So we just created this graph. It's the best sine graph I've drawn all day. Okay? So the question is, now, how do we have to shift the blue one to get what we've got? So how do we have to shift the blue one to get what's given, the black one? So what kind of shift would we need to do on this to get it to lay on top of the one that you were given? Which way you want to shift it? She wants to shift it right. So the question is, how far? So we got to look here and maybe pick off some points. So I'm gonna rewrite this in blue because it's our blue graph. Okay. So our blue graph is 3 sine 2 theta minus 1. That should make sense so far. We moved it down 1, stretched it 3, and it's going twice as fast as the normal sine, right? It's cycling twice as fast. So now we need to shift it. We want to shift it right, and the question is, how far? Yeah, I mean, it's really kind of hard to say exactly. So this is 1/4 pi. So this is pi over 4. And it looks like the top of this is about 2. I don't know. So how far are we shifting it to the right? That shouldn't be hard. And so when we shift it to the right, first of all, so will it be the one we shift to the right, our new one, will it be behind the blue one or ahead? So think of this as time going by. Which comes first, the blue, so the blue one or the red one? Blue one comes first, right? This is starting. Now this one starts as you go from left to right. So this is behind an angle, right? It's behind an angle, so we can subtract or add? Subtract. So theta minus. How far behind is it? Yeah, so maybe this is 3 pi. Maybe this is 3 pi over 4. What's 3 pi over 4? No, that's not 2. No, 5 pi over 4. Anyway, the best we can do is we're picking up. This is x equals 2, and this is our pi over 4. So how far behind is it? How do you get that quantity right there, that interval? Yeah, so what would it be? What value? I'm not, just give me the expression. Give me the expression. No, not 2 pi over 4. What expression will give you that value? What? 2 minus pi over 4, right? 2 minus pi over 4. That's just as a legitimate number, even better, actually, than what you would get if you put that in your calculator. So don't be afraid to express numbers as expressions. That's a perfectly valid number. In fact, that's the only exact way to represent that number. As soon as you put it in your calculator, you've got an approximation. Even if you take 100 decimal places, it's still an approximation. So we're shifting it to the right, 2 minus pi over 4, which means we're subtracting 2 minus pi over 4. Now, I sent the email. Did you get the email? You got to have it this way. The 2 for our changing the period has to be outside of this, the phase shift. So I'll write it again. You want, just inside, you want 2 times theta minus this number. Okay? That's how we can make sense of it, that we're making sense of it. It's shifted over this far in theta, and then the period is half as much, or it's cycling twice as fast as the normal sine. Okay, so lots going on there. Anybody have a question? Do you follow that? Do you want to take a couple minutes and try C or... Oh, yeah, go ahead.
So if it's like numbers like 1, 2, 3, you just have to put it in terms of pi.
To do, what's that?
Like you said, it's pi over 4, like right where the top of that line is. So you just have to like know what pi over 4 equals like, in terms of the 1, 2, 3.
So all of this is we're just kind of picking off numbers, first of all.
Yeah.
But I drew the sine curve with a period of pi. So I knew that that top was exactly at pi over 4. Does that make sense? Because I drew this blue one, which is sine with a period of pi. So that's exactly 1/4 of the rotation. So that's why I knew that's why I picked off that was pi over 4. In terms of picking values off the black one, I just said it's close to 2, so let's just use 2. You see? So yeah, when you're making these expressions out of graphs, it's not exact science. But it was for the blue graph because we said let's just graph the sine. We know exactly where the top of that is. Other questions? Yes, sir. Absolutely. Yeah. Yeah. So you could have said, what is that? 0.7 and called this 1.3. Is that what you mean? Yeah. So we could have estimated that's maybe, what is that? 0.8, 0.7, and then so that would be like 1.2. And so that number would be 1.2. Yeah. So 2 times theta minus 1.2. What is 2 minus pi over 4?
1.214.
1.214. So 1.2. So 3 sine minus 1. Perfectly legitimate. Other questions? But what you don't want to do, here's what I'm warning you against. This is not correct. 3 times sine of 2 theta minus 1.2, like this. This will be a different graph, right? This is not the same graph. So if you want to have the phase shift right, you want 2 times that thing in parentheses with your horizontal shift. So be careful for that. Okay, do you want to try C? Take a couple minutes and work on C, and then we'll regroup in a minute, or do you want me to just do it? What's that?
What I've come across is just like it's hard to figure out what number to get it to stretch. I don't know. Does that make sense? To
Yeah.
figure out it's a lot of
So,
guessing, like punching
yeah.
numbers, and so I don't know if there's a way to.
All right, let's do it together. I'm going to erase what's up there. Is that okay? Yeah. So our final answer was the red one, or this black one down here. That's what we got. Okay, so now this one. Midline. Let's start with the max and min. What's the max?
2.
We'll go faster. 2, min, 0, midline, 1. How will that affect the equation?
Add 1.
We're going to add 1, right? We're going to add 1. Okay? Amplitude. 1. How's that going to affect it? Nothing. We won't have to multiply, right? So is this cosine or sine? Cosine. Amplitude is 1. So all we got left is what's in the parentheses. Okay, so what is the period here?
12.5.
So about 12.5. Notice that halfway is right here. What might that be? Yes, remember 2 pi is like 6.28. It looks like that might be 2 pi. But if you want it, so this might be then the full period. 4 pi, you could estimate it to be, or you could estimate it, what did you say? 12.5? Either are acceptable because you're just estimating from the graph. So for the period, either 4 pi or 12.5 or something close to those. So now, this thing in here is our input theta. It needs to be 2 pi when theta is, so which one do you want to use? Use 12.5. Okay, so inside here will look like this, b times theta. So b times theta has to be 2 pi, 1 cycle, when this graph, theta is 12.5. So b times 12.5, we ought to get 2 pi that goes into sine, or cosine, to make 1 full cycle. So b is 2 pi over 12.5. So that value of b that gets us the right period is 2 pi over 12.5. Amplitude is 1, so we could put 1 or just leave it blank. And then we're going to move up 1. So there it is.
So to get that,
Can you read that? This is
b theta goes.
yeah, so b theta is generally what we're putting into cosine and sine. So when we get a full cycle of what's given, the b theta needs to be 2 pi to get a full cycle of cosine. And so then you're solving for that, what is that coefficient b that will make that whole thing equal to 2 pi when theta does a full cycle. Question, sir? Yeah?
So for the previous one,
Yeah?
you got to frequency theta.
Yeah?
Could you just do 2 pi over equal to what we're on solving here and get the same?
Mm-hmm. What's that? Yep. Question? Okay, so let's talk about that. So if we know the period is p, we want b theta to equal 2 pi when theta reaches this value of the period. So b equals 2 pi over p. So I'm a bad teacher for not telling you the formula. It was very intentional, but we've done enough of them so that we can do that. But memorizing formulas doesn't really get you very far, especially if you forget the formula. Yes, sir?
For the previous one, depending on which way you want to say the graph shift is
Yeah.
cosine or sine,
Yeah.
you go.
Yeah, so that's a good point. Any more questions about C? Let's go back and talk about that. Any more questions about C? Yeah, so the mathematics is this process of understanding what period is, right? So that's why I've emphasized that, thinking through that process every time. All right? So you can know that B is 2 pi over P and you can learn nothing, right? But you can do it enough times, understand that process, and then it's kind of like you have the authority to create that formula and use it, right? So that's what that's about. Okay, so back to this one. So what if we wanted to make that a cosine? It would start here and would make it back to where we said 3, like this. And so 1.57 is here. So if we wanted to do a cosine curve, that's the worst one I've drawn all day. Okay. So what would we need to do? How would we need, if we wanted to write it in terms of cosine, we know it's 2 times b theta. How we want to shift cosine, so here's our cosine curve. How do we want to shift the blue one to get the black one? So let's shift it left this time. So how far left would we need to shift it? Right, that far, right? So from 0 to, what is that? We picked that off, about negative 1.25. So then how do we change the angle theta of the cosine to get the black graph? Yeah, it's going to be ahead of it, right? So it's coming first now. So the graph we want comes before cosine. So we're going to add 1.25. So this, yeah, still the -1. And then still, what is this? 3? What was that? 3 and then -1. So another way to write the same graph as a cosine instead of a sine, do the cosine shifted left 1.25. Make sense? Yeah. So all of these can be written as sine or cosine. Okay, what else? Is it like 98 and 99 or something? Take your pick. Oh, and then we have the tide problem, right? We have the tide problem. Okay, so between the tide and the buoy and the Ferris wheel, which one do we want to do? So we got the buoy, and we got the tide one I gave you, and we got the Ferris wheel. So while you still have a little bit of energy left, let's do the most important one first. So all in favor of the buoy? Don't be afraid. All right, all in favor of the tide? All in favor of the Ferris wheel? Ferris wheel edges it out. So here's this. Okay, so large Ferris wheel's famous landmark, function below, person's height above the ground in feet, as a function of the number of minutes they've been on the eye. The amplitude of F. What's the amplitude? 221. What's the period of F? So here we've got this thing. It's the same process again. So pi t over 15. We're asking what value of t is going to make that whole thing equal to what? 2 pi. And so if you solve for t, I'm hearing that you get t equals 30. What value, so you're saying what value of t is going to make the input into cosine be 1 cycle or 2 pi? T equals 30. All right. Determine the function h that relates the height measured in feet as a function that's how long they've been on the Ferris wheel using the sine function. Oh, so it's the same one but using sine instead of cosine. Is that right? Okay. So if we've got the opposite of cosine, so imagine what cosine does. Opposite of cosine will be what at 0? Min, midline, or max? So positive cosine starts where? At the top, at the max. So negative, start at the bottom. So this is kind of now making the most sense because we board this thing at the bottom, right? We're going to board it at the bottom and we're going to go up. And so, oh, but this is horizontal distance. No, cosine, that's right. No, but this is the height. Okay, so, all right, good. They're modeling height, but they're using cosine. Okay, so we got to think about this. They're modeling height, but they're using cosine. Does that phase us? No, because we know that all sine curves can be written as a cosine, and all cosine curves can be written as a sine. So normally we'd think of that as sine at first, but we know it could be written as a cosine. So it makes sense because it's starting at the minimum. That's where your height would be at the bottom. So it'd be like that. So now we need to write the same function as a sine curve.
So what are you saying it's starting at then? At 0?
Nope, not at 0. What height does it start at?
Because when I graphed it, that's where it started at. I'm sure it starts at 0. And I put it like that.
Oh, right, 0, because it's negative 221 plus 221. So yeah,
Starting at.
thank you. So the actual x-axis should have been here. That's where 0 is. Okay, so this is now, that's the x-axis. The red is the x-axis. Yeah, so it starts at 0, like ground level. So we need to write the same thing as a sine curve. So if it were, so what we said the period's 30, so this right here is 30. So sine normally would do this. Is that right? Wouldn't that be just our sine? So yeah, let's do that. So let's write that down. That would be 221 sine of pi t over 15 plus 221. Negative. Okay, but no. So the way I drew it was positive. I drew positive. So moving it up 221 with an amplitude of 221. I went up first, right? So that red graph that I just drew right there, it's just the positive sign of the exact same function that we just had. So how do I need to shift sine so to get the blue one? How do I need to shift sine to get the blue one? You want to shift it to the right? So the question is, how far is that? Then I'm going to shift it. So think of it in minutes, in time in minutes. How many minutes into the cycle is the top of the sine curve that I drew? If the whole cycle is 30, then how many minutes is it at the top? It'd be 1/4 of 30, 7.5, right? And how many minutes is it to where I need to shift that to the top of the cosine curve?
15.
That's half of the half of the period of cosine, 15. So how many minutes do I need to shift the sine curve to the right? 7.5 minutes. I need to shift that thing to the right. So shifting to the right, is it behind in time or ahead in time? Behind in time. So minus or plus? minus 7.5. There's no guessing in this one. Everything was precise here. I got all those values I got from this. The cosine starts at 0. Halfway, it's 15 minutes. All the way, it's 30 minutes. I drew the same sine curve in that same period, and we know a quarter of the way is a quarter of 30. So that time shift is exactly 7.5. All right, so if we graph that, we should get the same thing as the original one. Is that the end of the problem? C?
No, there's more.
All right, let's just do this much.
Equation that lined up.
Yeah, there's more than one. Yep.
Okay. Mine's just doesn't make sense.
Does mine make sense? So y equals negative 221 cosine of pi over 15 x plus 221. Let's just look at that first. We gotta zoom out here. Okay, so if I graph this new one that we just built, y equals 221 sine of pi over 15 times t minus 7.5 plus 221. Should be the exact same graph. Doesn't like it. X. Okay, it's the same. Same graph. We got it. Okay, can I erase what I wrote on the screen? Can we go on? I'll save that. So, distance traveled using the cosine function. Twice as fast, radius is doubled. Those are easy. So the harder one is D, right? So we need to, what did it ask for again?
In feet. The distance traveled
In terms of distance traveled. So this right now is in terms of pi over t. Pi t over 15 is our, that's radians. So we need a new expression for radians that uses distance traveled, so we'll call it d. D is arc length traveled. So we need an expression of theta as an expression of arc length traveled, or not f, something else, called g. Okay, so how are we going to get the arc length? We've done this before. Theta is, how do we get the number of radius lengths from the arc length? We take the total arc length and divide it by the radius, which is it 221? So however far you've gone, if you divide by 221, that's how many radius lengths you've traveled. And that's what we can instead put in for that. So instead of pi t over 15, we want d over 221 for part D. Does it make sense? So we've seen this a couple times now. Theta is number of radius lengths. To get the radius lengths from distance, you're going to divide by the length of the radius. We want to rotate it twice as fast as this. How do we rotate this twice as fast as before?
multiply pi t over 15 by 2.
So if we multiply this by 2, will it make it rotate twice as fast? what will happen to the period when we multiply it by 2?
Double.
No, it'll shrink, right? When we're multiplying by 2, shrinks it. So if we shrink the period by 2, it's going faster. So all we need to do is multiply that thing by 2. Let's try it on the graphing calculator. So I'll keep the sine, the one we developed. Oops. And so we'll take that original one. If we multiply it by 2, it ought to turn twice as fast, and it does. So that's the pink one. Turns twice as fast. Okay, and then radius is doubled. How do we double the radius of it? So we'll go back to the original. Now we want to double the radius. What would we do?
222.
It'll be, this will be, the new amplitude will be 442. Is this right now?
Yeah.
No, but then we got to move it up also that much. So there it is, doubled. So same rotation speed, but now it's doubled. Okay. Finally. Yeah, we did all that. Okay, questions about that problem? Okay, so you can put your finishing touches on and bring it again Friday, and you can use it to study. So bring it again on Friday. Oh, and where's the homework being returned? Who has not seen that yet? Down in the. Can you hand that to her right there? Right behind you. Question. Hold on a sec. Hold on a sec. You can leave quietly, but there may be questions. What was it again? Okay. We're actually not done. So if you're leaving, you're sneaking out like because you have an appointment. Okay? You need to hear this question. For C, why is the amplitude the sine curve? Because there's lots of ways to do it. So I started by saying let's just graph. This is what I did. I started by graphing it positive. Dang it. So here the pink one's the original, right? Please don't start talking. Thank you. All right, so the pink one was the original. And I said, let's just graph it positive, and then we'll ask, what phase shift do I need on positive sine to get the graph I want? So then I said, okay, we looked at the positive sine. We said, if I took the positive sine and shifted it 7.5 minutes to the right, it would do it. If you want to start with a negative sign, that's valid. You could just start with negative. You'll have a different shift now. Okay, so now you'll have to say, here's negative sign, the blue one. Now, how much am I going to shift negative sign to get the pink one? So the easiest one there would be, okay, now I got to shift negative sign, I got to shift it back. So if I do negative sign, I'm going to have x plus 7.5. They both work. Does it answer it? Okay.
So now I got like.
In fact, there's an infinite number of ways to write any of these. You can keep shifting by a period every time, and you keep landing on itself, right? So you got what?
I was off altogether. I just have like decimals, and I had like 0.21x plus pi.
Yeah, no. So the key is to see this thing as 30, and these are all these fourths of the rotation are 7.5 minutes. So that it's going to be some multiple of 7.5 that you're going to move it left or right. Okay, so I have office hours today. I'll be in my office, or email me ahead of time, but like middle of the day tomorrow, and I'll be in the testing center from 2 to 3. So if that's a good time for you to take the test, I'll be there for that whole hour. Okay, so study, get your questions answered before the test. See you Friday. Oh, last day for the post test today. You got to be in there by 6:30 today. Post test.